Lesson 18, Video 2. So we were talking about the expected number of times spent in a transient state given that you started, or the system started, in a different transient state. So from the last video we had S of ij is delta ij, that's just the staying in the same state, giving one period for that, plus the sum product of the probability of going to each possible intermediate state times the expected number of time periods spent in state J given that you were in the intermediate state. So if you put this in a matrix form, it looks like this. So the matrix of these S values is I, which is just the delta transformed into a matrix. So the identity matrix plus your transition probability matrix times your S matrix. So to solve for S, we would have to do a little bit of matrix algebra. So for this we say, okay, we want to get, we're going to take this over, so we're going to say, since this is really IS, we're going to say I minus P of T, these are all matrices, times S. That was just this guy moved over to there, and then I factored out the S. Again, took this term here, factored out the S, and that's the same I. It's just equal to the identity matrix. Okay, so now I'm going to pre-multiply both sides by the inverse of this first matrix. So I minus PT inverse, and in front of this guy, well, you can put the identity matrix before or after, you're going to get the same result. So I can get away with this only because it's the identity matrix. So now I'm going to have these guys are going to become the identity matrix, and this thing stays. So S is the inverse of the identity matrix minus that PT, that partial single step transition matrix. So this right here is what you need to use. Alright, so we're going to do an example. Let's take this little system up here. So we have one class of transient states and one absorbing state over here. So we know that the probability of going from state 2 to state 2 is just 1. So the probability of going from state 0 to itself, 0.5. From state 0 to state 1 is 0.5, and it doesn't go to state 0. State 2, sorry. State 1 goes back to state 0 or goes to state 2, and this one we've already said only goes to state 2. So do these things add up to 1? Yes, yes, yes. So we've got our rows with total probability. Okay, so now I'm going to take PT out of this guy. So I want to not worry about state 2. So I'm just going to look at this upper set. So I'm going to go, this is going to be 0.5, 0.5, 0.75, and 0. So there's PT. And if I want to find my S matrix, I'm going to use I minus PT and take the inverse. So 1 minus 0.5, 0 minus 0.5, 0 minus 0.75, 1 minus 0, inverse of that is equal to 0.5 minus 0.5 minus 0.75, 1. And if I invert this guy, I'm going to get, see, and I did this in MATLAB and ended up with 8464. Okay, so this is S00, S01, S10, S11. So if we start in state 1, we expect to spend 4 time periods in state 1, for example. So that was S. Okay, so now we know our expected time spent in each transient state given that we started in whichever transient state we started in. So let's look at, and one more piece of information, Fij, we're going to find that as a probability the system goes to state J given it starts in state I. So we have our S matrix, probability that we're going to go to, that the system is going to make it to state J given it started in state I. And that's just the probability Sij, which is the expected number of time periods spent in J given you started in I, minus delta Ij divided by Sjj. And so, for example, in this case, let's say we want to know the expected number of time periods spent in state 0, given that I started in state 1. So f of 1, 0, f1, 0, probability the system is going to make it to state 1, given it started in state 0, is s1, 0 minus s1, or delta 1, 0, which has to be 0 because delta 1 and 0 are different, divided by s0, 0. So I'm just following this formula here. And I get S10, which was 6, and I have S00 is 8, and I'm going to use a 0 for this one, and I'm going to get 0.75. So we will do another one of these examples in class tomorrow, looking at time expected tuition in college, and see you then.